Okay. What on this list are you familiar with? Stem and leaf plots, dot plots, pie charts.
Oh, it's a
P-I-E, yep.
That does a thick charts.
Because my E looked like a C. Which ones are you familiar with? Not necessarily making them, but like you've seen them, you know what they are.
Bottom ones, I think.
Dot plots?
They're just dots, right?
Are you thinking like a scatter plot?
Right.
That's not the same thing. We will do that tomorrow.
Pie charts.
Pie charts for sure. Everybody okay with that? What's stem and leaf plots? Have you done that in a math class before?
I feel like I learned it, but I have no clue.
Okay. We're going to use the data from yesterday, which I wrote down. I feel like I did. And threw it in my desk. Haha! All right, Windows. Our data from Windows yesterday. We had 7, 10, 15, 16, 20, another 20, and a 32. And then I'm going to add a couple more numbers in. I'm going to add 45. Let's pretend we had someone super rich, which we don't, so, or at least I assume none of you guys are millionaires and you weren't telling me. I'm just going to add a 45 and a 63. Okay. So a stem and leaf plot looks like this. Stem and leaf plot is used to organize data, mostly. It is used for quantitative data. Means numbers that mean something. And it looks like this. So you kind of have a line like this. And then on one side, usually we put the tens on the left and the ones on the right. So I'm going to put 0, 1, 2, 3, 4, 5, 6. Why do you think I chose those numbers?
Goes all the way to 60.
Yeah, it goes all the way to 60. Why do you think I put a 0 on there?
Less than 10.
Yeah, so 7, right, would count there. By the way, you don't always have to start at 0. You start at whatever the lowest thing is. So if it was like, how old were you when you retired? There'd be no reason for 1s, 2s, 3s. Like we'd probably start around the 50s or 60s, you know, depending on how old our data was. All right, so then you start organizing it. I've got a 7 here. And this is a 10. Notice that I'm just putting the 1s over there. Comma, 5, comma, 6. Here we've got 0 and 0. Next to 2 or 3, I've got a 2. Here I've got a 5, and here I've got a 3. Do you see how you can just glance at this and visually see where most of our data is? It's really on this side, right? Our data's on this side. So see, it's kind of like lumped in right here. We got one outlier down here. Why do you think I left the 50 category in there? If there's nothing in there. Autumn?
Because there's nothing in the 50s.
Right, but I mean, like, why even put it in there then? You're right, that's why it's empty. Yeah?
Because if you didn't have it there, like, it wouldn't necessarily look like an outlier, it just looked like another piece of data next to
Right,
it.
I kind of am trying to visually show that this group is different than this one. Now, if you do have a huge stretch, there is no reason to have all of that blank space, and you can write like a dot, 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 and then like jump if you want to. Yeah, so you have to be reasonable about your data. You don't want a line that is forever long because everybody's in the tens except for one person who's in the 250s. Okay, the other thing you have to have with a stem and leaf plot is you have to have a key nearby. You just pick a number. This doesn't have to be a number that is on the chart. And I say 4-6, that is equal to 46. So I'm just kind of explaining to somebody that if they were looking at it. And also, usually it wouldn't have the title tens or ones next to it. It would just on the key explain what your thing means. And if you're wondering, but why would we need that if it's always tens on the left and it's always ones on the right? It's not. Sometimes it's hundreds on the left and tens on the right. Sometimes it's decimals. So it would be like ones over here and then like tenths over here. Like suppose I was talking about grade point averages. I might have like 0, 1, 2, 3, 4. And then it would be like this, somebody would have a grade point average of 0.7, 1.0, 1.5, 1.6, 3.2. 4.5 is not realistic unless you're in an AP school that does that, but you know what I'm talking about. So most often, it's the bigger thing is on the left, and well, always the bigger thing is on the left and the smaller thing's on the right, and most often it's tens and ones. But sometimes they use decimals and change it up. For example, here is numbers of text messages sent. This is still tens, you see, but notice that here they have some that are 15, and if you have 15 tens in a 5 in a 1 spot, that's 155. They also have examples. I don't know if they have any more good examples. Wish they did. I'll find one for you and show you. Okay, let's move on to dot plots. So a key is always important to have on the side. All right, we're moving on to dot plots. Dot plots are also quantitative. By the way, all of these things do not need to be on graph paper in your homework because these are not as you don't need straight lines as much, especially with a pie chart. But when we do graphs on Monday, you will need graph paper because those will be more histograms and, well, I guess a bar chart and scatter plots. And scatter plots definitely need graph paper. All right, a dot plot looks more like this. It looks like a number line. This is also quantitative data. And this also helps with organization and looking at the big picture from afar. Let's see, we're going between what, 7 and 63? So I'm going to start here at, I think I'm going to go by tens. I'm going to go 0, 10, 20, 30, 40, 50, 60, 70. I'm labeling it at the bottom, windows in our houses. So with a dot plot, you just put numbers on the number line, not on the number line, but above it. So like 7 would be here, and here's 10, 15, 16. If you have two that are exactly the same number, they start stacking on top of each other, like that. So eventually they're going to really stack. 45, 32, 63. So on this one, every dot is a data point. This also really helps us kind of see where outliers are, where most of us are, down here, right? If you wanna see a picture of it like this, really shows how they can start stacking up and you can start looking at the data. So this is good, especially for large amounts of data, where you can kind of see where most of it is. Everybody okay with that one? Great. All right, let's do something funny.